Hello everyone. For this session, I'm going to discuss about how to write chemical formula and how to name compounds. So, chemical formula of compound is simply the chemist's shorthand or chemist's representation of compounds using their symbol and oxidation number. And when we say oxidation number, this is an effective charge of an atom in a compound. For ionic compounds are compounds formed by ionic bonding. So this is the compound formed by the attraction of the cation and the anion. And in writing chemical formula, always remember that the sum of positive charge and negative charge must be equal to 0. So they have charges that are neutral. Say for example, if you have aluminum and nitrogen. So if you're going to check the symbol for aluminum, it's Al and its oxidation state is positive 3. Nitrogen is N and its oxidation is negative 3. So if you are to check the positive and the negative, it's equal to 0. And therefore, its formula is simply AlN. Now for compounds or for ionic compounds where the oxidation state is not equal to 0, you may apply the following steps. First is you have to think of a multiplier to make the total charge of the cation and anion equal to each other. And then use that multiplier as a subscript. And then write the formula. Take note if the subscript is 1, do not include that in the formula. So say for example, if you have lithium oxide, so for lithium oxide, you check the symbol. So for lithium is Li, positive 1, and oxygen is O, negative 2. If we are to examine the summation of the charge, is not equal to 0. Positive 1 and negative 2. So, to make the positive and the negative equal, the subscript to be used are, for lithium, it's positive 2, and oxygen is 1. So if you're to look at the summation of the positive and negative, it's now 0. So 2 for lithium multiplied by 1 is positive 2. And 1 as the subscript for oxygen multiplied to negative 2, so it's negative 2. That's why the ratio of the lithium to ion is 2:1. And since 1 is not written in the chemical formula, it's not included in the chemical formula, our formula for lithium oxide is Li2O. So if you are to check the oxidation charge for lithium and oxygen, you will notice that they simply exchange. It seems that the positive and the negative just simply cross over and the charge was dropped. We call that method as crisscross method. So in writing formula of the compound, we can apply crisscross method. So crisscross method is simply crossing over of the oxidation number, but the charge will be dropped. Say for example, if you have sodium and sulfur. So sodium is positive 1 and sulfur is negative 2. So if you do crisscross, negative 2 for sodium, so 2, you are going to put that to sodium, and 1, you're going to put that to sulfur as a subscript. Therefore, its chemical formula is Na2S. So the positive charge and the negative charge here is equal to 0 because 2 multiplied by 1 is positive 2 and 1 multiplied by negative 2 is negative 2. Okay? And then, you look at this example, if you encounter this one, so for the compound lead 4 oxide, so in getting the symbol for lead, it's Pb, and this charge is positive 4, and oxygen is negative 2. If you crisscross the oxidation number, so we'll have the formula Pb2O4. But take note, looking at the subscript 2 and 4, if you notice, these numbers are still divisible by 2. So we can still simplify the subscript into 1:2. And therefore, the final chemical formula is PbO2. So please do not forget that. If you encounter such case wherein you can still simplify the ratio of the element in the compound, please do so. For compounds containing polyatomic ions. So when we say polyatomic ions, these are ions which are group of atoms chemically bonded. They function up as one and carry a charge. Okay? So there are lots of examples of polyatomic ions. And again, take note, they are a group of atoms, they function up as one and carry a charge. So when a compound contains polyatomic ion, how are we going to write the chemical formula? Say for example, we have calcium nitrate. So again, similar to what you are doing with binary, you check the formula, the symbol for calcium and the oxidation state, and you check also the formula for nitrate and get its oxidation state. You may also perform crisscross method to write the chemical formula. Okay? So again, for calcium is Ca positive 2 and nitrate is NO3 negative 1. So when you crisscross it, the chemical formula will be Ca open parenthesis NO3 close parenthesis 2. So since there is a subscript after the polyatomic ions, do not forget to write open and close parentheses. Okay? So this is for polyatomic ions. Another example is for potassium and sulfate. So we have potassium sulfate from potassium ion and sulfate ion. So you check the symbol for potassium and you check the formula for sulfate and the oxidation number. So potassium is K, positive 1, and sulfate is SO4, negative 2. So when you crisscross it, what is the formula of the compound? Okay, so this is K2SO4. So 2 came from the sulfate ion, and since potassium is positive 1, there will be no subscript after the SO4. So no need to put a parenthesis. So for naming, let's move on to naming. Naming binary compounds consisting of metal and non-metal. You name first the cation or the metallic elements, followed by the non-ion with the IDE ending. So only the anion, the non-metallic elements, will end in IDE. Examples are carbon is carbide, we have sulfur, sulfide, oxygen is oxide, chlorine is chloride, fluorine, fluoride, and so on. So always remember that it's the anion, the negative charge will be changed to IDE ending. Say for example, if you have the compound barium and chlorine, so the formula is BaCl2. So name first the cation, which is the cation here. Okay, so it's barium. So you use the name barium followed by the name of the anion, which is the chlorine. So instead of chlorine, the name will be chloride. So when you put them together, the name of the compound is barium chloride. Okay? Okay, so for example, if you have this compound, what will be the name of this compound? First one, name the cation. So Ca is calcium, and the anion is chloride. So this is named as calcium chloride. For the second example, let's have Al. Al is aluminum. Fluorine is now fluoride. So its name is aluminum fluoride. For the last one, potassium is K and chlorine is chloride, and therefore the name is potassium chloride. So again, the technique for naming compounds consisting of metal and non-metal, name first the metallic element using its full name, followed by the non-metal with the IDE ending. What about for cations with multiple oxidation number? So there are metallic elements where the oxidation number is not just 1, but more than 1. We have 2, we have 3, we have 4. So how are we going to name these compounds where the metal has multiple oxidation number followed by the non-metal? In this case, we're going to make use of two methods. First is the stack. When we say stack system, the Roman numeral is used inside the parenthesis to indicate the oxidation state used by the compound. If it is classical, the old name, we are going to make use of the Latin name of the element, and then we're going to make use of OUS ending for the lower oxidation state and IC ending for the higher oxidation state. Say for example, if you have the element iron, so there are two oxidation number, positive 2 and positive 3. For iron, positive 3, its stock name, say iron positive 2, rather, its stock name is iron, parenthesis, Roman numeral 2, and then for iron 3 is iron, and then Roman numeral 3 in the parentheses. But if you are to make use of classical, it's ferrous and ferric. Ferrous for the lower oxidation number, and ferric for the higher oxidation number. Same also with lead. So from the word plumbum, lower is plumbus, higher is plumbic. But if you are to use the stock system, it's lead, it's the real name of the element lead, and then parenthesis Roman numeral 2. If it is 4, so you have lead, and then open parenthesis Roman numeral 4, and then close parenthesis. So these are the examples. Okay? So if you are to write the stock name of FeCl2 and FeCl3. So if you are to consider iron, iron has two oxidation number, positive 2 and positive 3. So how are we going to name the compound if the compound make use of the lower oxidation number, which is 2, and the higher oxidation number, which is 3? So looking at the example, so FeCl2, so obviously from the formula, the compound make use of 2. So in naming that using the stock, it's iron, then 2, Roman numeral, and then chloride. But if the compound make use of a higher oxidation number, which is 3, so it will be named as iron, then Roman numeral 3, and then chloride. For the classical, using the same example, for iron 2 chloride, it will be named as ferrous chloride. It's lower. But if it is higher, it will be named as ferric chloride. So, if you are to make use of stock, again, it's Roman numeral in the parentheses. If it is old, you are going to make use of the OUS IC ending. OUS for lower, and IC for higher. Okay? So say for example, this one, if you have for copper and oxygen. So for the formula, formed from the elements copper and oxygen, will have Cu2O and CuO. So here, to name the first compound, in the first compound, copper makes use of a lower oxidation number. And it's obvious in there's no subscript in the element oxygen. So we name it as copper 1 oxide. In classical, it's cuprous oxide. In the other compound, CuO, copper makes use of positive 2. So it's copper 2 oxide, and because it's higher in classical, it's cupric oxide. Okay? So what about in naming ionic compounds with polyatomic ions? Here, name first the cation followed by the polyatomic ions. Name first the cation, then followed by the polyatomic ions. Example, if you have ammonium and sulfate. So the cation here, the positive is the ammonium, and the polyatomic ion is sulfate. So this is actually a combination of two polyatomic ions. But in the rule, name first the cation, which is ammonium, followed by the polyatomic ion sulfate. So this compound is simply named as ammonium sulfate. So say for example, if you have NaNO3, the cation there is sodium, the polyatomic ion there is the NO3. So Na is named as sodium and NO3 is nitrate. So its chemical name is sodium nitrate. For the second example, the name of the cation is ammonium, and then the second element will end in IDE. So instead of ammonium chlorine, it's named as ammonium chloride. And for the last example, take a look at the cation used. It's iron. If you are to go back, iron has 2 oxidation number. So in this formula, iron makes use of higher oxidation number, which is positive 3. So in naming this, in stock, it's iron, Roman numeral 3, then parenthesis, and then hydroxide. That's a polyatomic ion. Or in classical, it's named as ferric hydroxide because 3 is a higher oxidation number. Okay? Okay, so this will be the name of the compounds. Now, what about for binary molecular? So, a while ago, we talked about binary ionic and ternary ionic compounds. This time, we have binary molecular. So, these compounds are, its smallest particle is actually a molecule. These are compounds formed by covalent bonding or sharing of electron. So for covalent compounds or binary molecular compounds, these are compounds composed only of 2 non-metal, but this is a combination of hydrogen and elements coming from groups 14 to 17. Groups 14, 15, 16, 17. Okay, only element hydrogen and elements found in groups 14 to 17 form molecular compounds. How do we name them? The rule for naming binary molecular is entirely different from binary ionic. Why? Here, the first element in the formula is always named first element. Using the entire name of the element. The second element in the formula is named using the root and adding the suffix IDE. Chlorine, chloride, fluorine, fluoride, similar to binary ionic. But take note of this. Greek prefixes are used to indicate the number of atoms of each element that are present in the compound. So the number that you will see in the compound as subscript will be represented by Greek prefixes. Take note of this because in ionic, we are not making use of Greek prefixes to denote the subscripts in the chemical formula. This time, in binary molecular compound, Greek prefixes are used. And what are these Greek prefixes? Okay? Mono for 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca for 10. Okay, you look at this example. Now, why is this a binary molecular compound? This is a combination of the element nitrogen and oxygen. So they are both, these elements are from groups 14 to 17. Nitrogen is from group 15 and oxygen is from group 16. So nitrogen and oxygen form molecular compound. They are not ionic. Okay? So you look at how each of the compounds here were named. First, N2O. So you see the subscript 2 in nitrogen. Here, you are going to make use of the prefix di, then the name, complete name of the element nitrogen, and then 1 is for mono, and then oxygen is oxide. But you have to remove 1O to make it not monooxide but monoxide. So dinitrogen monoxide. In the second example, you have NO. If you encounter an example like this, mono is only used on the second element. Kaya it's nitrogen monoxide. Okay, it's not mononitrogen monoxide, nitrogen monoxide. So again, the prefix mono will only be used for the second element. Here, for example, NO2, nitrogen dioxide. So 2 is di, oxygen is oxide. So second element ends in IDE. For 2 and 3, N2O3, dinitrogen, complete name, dinitrogen trioxide. Dinitrogen tetroxide. So instead of tetraoxide, remove the A and then it's now tetroxide, not tetraoxide. Then dinitrogen pentoxide. Instead of pentaoxide, it's now pentoxide. So 2 is di, N is nitrogen, 5 is penta, and oxygen is oxide. So this is for binary molecular compounds. Okay, so for example, if you have sulfur and chlorine, so sulfur from group 16, chlorine from group 17. Obviously, this is a binary molecular compound. So how will you name this? So check the number. 2 is di, S is sulfur, 2 is di, and chlorine is chloride. So it's disulfur dichloride. Look at the second example. Chlorine is from group 17 and oxygen is from group 16. So this is binary molecular compound. Di is 2, dichlorine, complete name. 7 is hepta, oxygen is oxide, and then remove letter A. So it's dichlorine heptoxide. So again, for binary molecular compound, Greek prefixes are used. Name the first element, complete name, followed by the second element with the IDE, and the subscripts are denoted by Greek prefixes. Okay? So now, what about for hydrated salts? How are we going to name them? Hydrated salts are compounds with water molecule in their chemical formula. And in naming, you name first the salt, the compound, the salt, followed by the word hydrate, but take note of how many hydrates were added in the chemical formula. Looking at number 5, in this example, you are going to make use of Greek prefixes still. So it's penta and then hydrate. So name first the salt. It's copper sulfate. Then 5 is penta and water is hydrate. So this is named as copper sulfate pentahydrate. Okay? Another. Okay, what about this one? So name first the salt. So Na and SO4. So this is sodium and sulfate. Sodium sulfate. How many water molecule is there in a compound? So you have 10. 10 is deca. And then the word hydrate. So this is sodium sulfate decahydrate. Okay? Last example, you look at the formula of the hydrates. Sodium carbonate decahydrate. So name first the salt, okay, sodium carbonate, and then 10 is deca, and then the word hydrate. Okay? So for acids, how to name acids? Acids are compounds with hydrogen ions or hydrogen in their chemical formula. There are actually two kinds of acid, binary and ternary. When we say binary, hydrogen and another element, non-metallic element. For ternary, it's hydrogen and polyatomic ions. Okay? How are we going to name binary acid? So, for binary acids, you begin naming by using the word hydro. So, the first will be hydro, and then the name of the element, and then the last is IC ending. The non-metallic element will end in IC. Hydro, and then name of the element, and then the name of that element will end in IC suffix. Say for example, HF. This is a binary acid. Why binary? There are only two elements found in the formula, hydrogen and a non-metallic element. So hydro plus fluorine is fluorine, but it's not hydrofluorine, but fluoric, and then add the word acid. So this is named as hydrofluoric acid. So the last will be the name acid. Say for example, if you have HCl, this is still a binary acid. It's hydrogen with another element, or with a non-metallic element. Start with hydro, then chlorine is chloric, IC ending, and then the word acid. So it's hydrochloric acid. That's for binary acids. Okay? So for ternary acids, acids containing hydrogen and a polyatomic ion. So how are we going to name ternary acids? So first, you have to look at the ending of the ternary. We have ATE and ITE. So the ATE ending will be changed to IC, then add the word acid. So there will be no hydro word in this ternary acids. If the polyatomic ions ends in ITE, you change that to OUS and then add the word acid. Okay? Say for example, if you have sulfate, so for polyatomic ion there, it's sulfate. So ATE, so it's sulfuric, and then add the word acid. If it ends in ITE, sulfite, it's sulfurous, OUS, and then add the word acid. So here, you see that the word hydro is not incorporated. Okay? So, ATE ending, change it to IC, then add the word acid. ITE ending of the polyatomic ion, change that to OUS, and then add the word acid. So, it's sulfuric acid, sulfurous acid. Another example is for phosphate and phosphite. Phosphate, change to 8ATE, change to IC. phosphoric, and then other word acid, and then for phosphite, ITE ending, change that to OUS, and then other word acid. So it's phosphorus acid. Phosphoric for ATE, for phosphite, phosphorus acid. Okay? So that's all. Thank you.